Graphically solving a system of linear equations. Graph the system below and write its solution. Y equals negative 1/3 x plus 1 and 2x plus y equals negative 4. Note that you can also answer no solution or infinitely many solutions. Alright, so the goal here is to take both of these lines and plot them on a graph and find out where they cross, or if they don't cross, or if they're the same line. Okay, so here's my graph that I'm going to use, but before I can graph, I have to consider how these equations are given to me. The first one I see is in y equals mx plus b form, or slope-intercept form, which means I'm going to be able to look and take the slope and the intercept right out of the equation. So remember that form is y equals mx plus b. So m is always the slope, which is the number in front of the x. So the number in front of the x here is negative 1/3, so that's my m, or my slope. And b is always the constant, or the number by itself. In this case, it's 1. So my y-intercept is 1, and my slope is negative 3. Now I always plot my y-intercept first. So it's a y-intercept, which means I'm going to plot it on my y-axis at 1 and put a point there. And then I'm going to move according to how my slope tells me to move. So I'm going to go down 1 for negative 1 and over 3, so to the right 3. 1, 2, 3. And I'm going to put another point. Now in order to be accurate, I'm going to count out my slope a few times. So I'm going to go down 1 over 3, down 1 over 3. Now I can also count backwards by going up 1, backwards 3. So it stays in the same line. Up 1, backwards 3, up 1, backwards 3. So I can see my line beginning to form. So I'm going to go ahead and grab my ruler and connect my dots, because that's my first line here. Okay, so there's my first line, my first equation, my first line on the graph. Now I want to graph this next one. However, it's in standard form. I can tell because the x and the y are on the same side of my equal sign. So I'm going to go ahead and rearrange this equation so that it's a y equals mx plus b equation. So I can graph it just like I graphed this one up here. So in order to rearrange it, I want to get y by itself. So in order to get y by itself, I need to move the 2x away. Now because it's a positive 2x, I'm going to subtract 2x from both sides. So those cancel, and I get y equals negative 2x minus 4. So now I have this second equation changed to y equals mx plus b form, just like this. So I'm going to be able to pull out my slope and my y-intercept and graph it like I did just a minute ago. So my slope, my m, is always the number in front of the x, so my slope is negative 2, and I like to put my slope in fraction form, so I'm going to put negative 2 over 1. And then my intercept is the constant, or the number by itself. In this case, that's negative 4. Okay, so I'm going to graph my y-intercept first. So I'm going to go down to negative 4 and put a point. That's my starting place. And then I'm going to move according to this slope. So I'm going to go down 2 for negative 2 and over 1 for the positive 1. Down 2 over 1, down 2 over 1. Now I'm also going to go backwards, which means up 2, backwards 1, up 2, backwards 1, up 2, backwards 1, backwards 1, backwards 1, and so on. So we can see my line here beginning to form. Now I'm going to go ahead and connect my dots and create this line. Okay, so on Alex you can just push the buttons and it creates it for you, but since I'm doing it on paper here, you'll have to watch me draw it. Now it says graph the system below, which is what we just did. So we answered the first part of this question. Now it says write its solution. So the solution is where the two lines intersect, which is right here. That point is negative 3, 1, 2, 3, positive 2. So its solution is going to be negative 3, positive 2. Now, if these lines were parallel and they never crossed, it would be no solution. If they were the same line, it would be infinitely many solutions. But because it crossed once, there's one solution, and that's what it is.